Assume that the power rule is correct, and we'll go ahead and use it repeatedly in order to differentiate some polynomials and other kinds of functions very quickly and easily. And so again, here's the statement of the power rule. Derivative of x to the n is nx to the n minus 1. So for our function f of x equals 2x to the fifth minus 4x cubed minus 7x minus 3, the derivative f prime of x will be the following. I'm going to differentiate each term. We had that property that said that the derivative of a sum was the sum of the derivatives, and derivative of a difference was the difference of the derivatives. So we'll differentiate term by term. Within each term, we had a rule that said that you could pull a constant factor out in front. So we'll have 2 times derivative of x to the fifth, so 2 times 5x to the fourth, minus 4 times derivative of x cubed, so 4 times 3x squared, where the exponent's coming out in front, and then in the exponent's dropping by 1. For the derivative of 7x, let's look at that on the side for a moment. So derivative of x to the first is like 1 times x to the 0th. X to the 0th is 1. So derivative of x is 1. So we're getting a negative 7 times 1. And then for derivative of 3, let's pull that aside for a moment as well. And so derivative of 3 should actually be treated differently than the others, although it sort of works to treat it the same. If you want to treat it the same, it's like a 3 times x to the 0th. And so we get kind of like a 3 times 0x to the negative first, which looks really weird but works since 3 times 0 is 0. A perhaps better way to look at this is that the function g of x equals 3 is a constant function, and its slope is always 0. And at this point in the course, you may have looked at the fact that the derivative function is a slope function. And since the slope of the constant function 3 is a slope 0, the derivative here is 0. And now we should just clean up our results here. And so we have 10x to the fourth minus 12x squared minus 7. And I want to just highlight that no one differentiates 3 by writing it as 3 times 0x to the negative first, but it's a way to force it into the power rule structure. And I think that now that I've mentioned it, I'm going to actually get rid of that explanation since no one uses that explanation, and just comment that derivative of a constant is 0. Okay, in our second example, we want to look at the derivative of square root of x minus 5x to the 1/3 power plus 1. Square root of x is x to the 1/2 power, and we'll use the power rule. Now, we didn't prove the power rule for fractional exponents, but it does hold for fractional exponents. So we'll have 1/2 x to the 1/2 minus 1. The exponent came out in front, and then in the exponent we subtracted off 1. Then we'll have a minus 5 times 1/3 x to the 1/3 minus 1. Again, the exponent came out in front, and we dropped the exponent in the exponent position by 1. And then derivative of the constant 1 is 0. And so cleaning up our results a bit, x to the 1/2 minus 1 is x to the negative 1/2. If we want to write that in square root notation, that's a 1 over radical x. So we have 1 over 2 radical x. Then we have a minus 5/3 x to the negative 2/3. And that's our result here. We have a plus 0, which doesn't change anything. Now let's look at differentiating this function h of x. So let me point out that 1 over x to the fourth is like an x to the negative 1/4. And so that fits the power rule structure as well. It's a power of x. And although we didn't prove the rule for negative powers of x, it does work. The second term, the negative 10 x to the negative first, again, x to the negative first is a negative power of x. And then for the 2 over radical x, that's like a 2x to the negative 1/2. So carrying out the differentiation, we'll have negative 4x to the negative 4 minus 1 minus 10 times negative 1 times x to the negative 1 minus 1 plus 2 times negative 1/2 x to the negative 1/2 minus 1. Now, as you get familiar with the power rule, you won't even have to write this intermediate step, and you'll just go straight to the final result. But here, let's simplify this intermediate step to finish things off. So we have a negative 4x to the negative 5th. We could write that as negative 4 over x to the 5th. We have a positive 10x to the negative 2nd. We could write that as a 10 over x squared. And we have a negative 1x to the negative 3/2. So that's a negative x to the negative 3/2. And that completes this example.